Bon, je peux le faire en anglais, ça marche. Bon, c'est vrai que tout le monde est bilingue dans le groupe, hein. Je fais en anglais, ou bien c'est bon, les slides sont faits en anglais. Et bon, pour la présentation, je peux le faire en anglais. Ça marche ou bien c'est mieux le français. Qu'est-ce que j'arrange? Allô? Allô?
C'est comme tu veux pour moi, hein.
OK. Le reste.
Alors, c'est bon pour moi.
OK. Yeah, my name is Rikel. I'm machine learning engineer working for a semiconductor company. So I've been in the field for about, I believe, seven years. So today, kind of going to go over the a high-level view of KubeFlow and KubeFlow pipeline, what it is, and how to use it with machine learning. So it's going to be a conversational type of presentation. So feel free to interrupt me anytime to ask a question. Right. So what we're going to cover in this workshop, we're going to start with having an overview of machine learning process and workflow, and trying to get into the container, how to use container in machine learning, then move to Kubernetes as one of the orchestration tool for container, then dive into KubeFlow and the KubeFlow pipeline. Then if you have more time, we're probably going to have some hands-on simple example how to run a KubeFlow pipeline. I'm expecting this workshop to be, trying to be around 1 to 2 hours, depending on how much question we have on it. So let's get started here. The machine learning workflow. As part of you already familiar, machine learning workflow consists of this sequence of steps, which are data gathering, create code to model, train and evaluate, tune the model, deploy your trained model, get the prediction, monitor the ongoing prediction, and manage the model and version. For example, if I'm going to build the simple image classification solution, so the first thing I'm going to do is to go and gather all the images that is available. I use that images as some type of cleaning, and then from the cleaning, I extract some feature. With that, I can now go ahead and train the model. Right? Train the model, evaluate the model. If I'm getting consistent result, then I can deploy that, put that for inference. Then I make some inference on it. Then doing my inference, I make sure that the model is not giving us a random output. So I have to monitor that model output. Then manage the model versioning. So meaning that if I'm going to go back and improve on the model, then I'm going to come back and update the version of the model with a better version of it.
Rikel,
alors?
S'il te plaît, est-ce que je peux passer à un mot de présentation?
Oh, ok. Yeah. Là, c'est mieux?
Ouais.
Ok. Bon. Then, when you look at that machine learning process, you tend to think about, okay, so the machine learning coding is taking most of the attention, most of the effort. That's what we kind of always perceive. And then other steps around it are just help to get the machine learning code. And we thinking that wow, by building the model, that's pretty much it, right? But in realities, we found out that building the machine learning model itself is taking less time than the other subsequence that we need to have in order to have the full solution deployed. So most of the data scientists spend time on Jupyter. They run the steps that I described already, but the build a model. Now from there, everything stays in the laptop or in the development environment. Now to move from that particular laptop on Jupyter Notebook to a production solution, it requires a bunch of steps. And that's why we want to go ahead and see how can we what tool can we use to make the deployment of the Jupyter Notebook code to a production code. In the very high level, machine learning again is the collection of a different step. Right? We already covered those steps. Now, looking at those steps, there's a lot of tight correlation between those steps, right? From the injection to the analysis, from that to the transformation, from that to the validation, from that to feature store. And then because of that, by changing one single step in the process require a full change of the solution. Right? You have a bigger impact on the entire solution. Right? So the idea was, okay, how can we find a way to decouple each of those steps to reduce dependency? So if one step breaks, it's not breaking the entire application. And that's what we kind of think about. How can we use the concept of container? I know container has been using for microservice for application development, and we're trying to use that same concept in machine learning, where we want to be able to put every step of the machine learning process into a container. And just for a quick reminder, a container is just a way of packaging software with all the dependency, right? And then you can also see container as a virtual machine without an hypervisor. Then by doing that, we can define each step of the machine learning process as a separate entity, separate microservice, which can run on a separate platform. That's an example of maybe if I'm using TensorFlow for model training step. Right? I can build a container using TensorFlow or the Python dependency, and then on that container, I write my code. So it's only going to be used for training the model. So the part that I'm doing from data preparation or data loading or feature engineering is not in this step. It's going to work on a separate container. And the thing is, the good thing about it is that we don't have to load all the ton of library across a particular platform, because we're only going to load what we need for that particular container. So I don't have to load every other packages, because in this case, because I'm only using TensorFlow and Keras and so on. So the other packages that probably need for deployment or for data training or data preparation. It's not good in this case. Then now that we know what container, how can we manage all those containers? Now that we have those, right? We break the machine process into separate containers. Now we have a bunch of containers. How can we manage those containers? That's where we're going to use Kubernetes. So Kubernetes is, in a nutshell, is a cluster management system. So by cluster, well, the collection of server or rack in the room, where each rack had a set of administration server on it, right? Because the rack is a bunch of servers. In between those servers, we pick 2 or 3 servers. We're going to be the master, put that way, the master servers, and those are the one who are deploying the job that we schedule across different servers on that rack. So at a very high level, so Kubernetes architecture is broken into separate components. You do have the master, which is few server, the top 3 server that we use to load all the packages that we need for Kubernetes. Then within the master servers, we do have the API server. The API server is pretty much is the brain of Kubernetes. So it's what we use to communicate between the user and the actual solution itself. From there, we do have the control manager. Control manager is again, it's like a thermostat. It's used to gather information and measure the state of the health of the entire Kubernetes cluster. Then we do also, in that master cluster, there's also a scheduler. Scheduler is what we use to schedule job and deploy job across different container or pod. And there's database, the AC database, the distributed database, which is the key value pair that we're using to store all the information that we need to run Kubernetes. Now, on the worker side, on the other servers, we do have different packages, such like Kubernetes. Kubernetes is in essence the software agent that we use to communicate with the master. There's also the concept of proxy, is pretty much what we need for network management between the worker and the master. And the pod, which is pod, you can see pod as Docker. Right? So now you have a bunch of Docker, bunch of pod around that we are putting on the cluster, ready to be used for deploying machine learning workload. And now we cover container, we cover Kubernetes. What is KubeFlow and why do we need KubeFlow and so on? So the Docker and Kubernetes are great tools. Right? They make the life the life of a developer easier. Right? But again, it requires a very steep learning, right? And very very depth. There's a lot of technology that you need to learn in order to go on and start using Kubernetes. Right? Now, KubeFlow came in and said, well, I can abstract all this learning from Kubernetes and give you an interface where you just need to plug your input and get the output. So you don't have to learn about cloud computing, Docker, Kubernetes, all of that. That you don't have to. worry about those things. Or you can, just know how to use the framework that KubeFlow is providing. Now, KubeFlow in a nutshell is pretty much a orchestration tool for machine learning. You just know the different of the tools like MFlow and Argo and so, but this is mainly define and focusing on machine learning workflow. It's very simple, portable, and scalable. You use that across is pretty much used across different industry. Different companies using it. It's one of the good tools for machine learning development nowadays. Yes, KubeFlow itself it's not one tool, but it's kind of the collection of different tools. But it has 4 major features, which is the notebook, which is pretty much is similar to a Jupyter notebook. So it's giving you, if you install KubeFlow on your system, you have that Jupyter notebook feature that you can run directly. So you don't have to go and install a separate Jupyter notebook. Give you that. The other feature that it has is the pipeline. Pipeline, which is what we're going to cover today in depth, which is pretty much the orchestration for the machine learning workflow. The training feature is pretty much a collection of operator like TensorFlow and PyTorch operator, which is a way of using TensorFlow and PyTorch within your KubeFlow framework. And it's serving. So now that the model is trained, is tested and validated, and it's good to go. How do you deploy it? Yes, you can make it an API, but serving help you put your model in production without wrapping up into an API. So KubeFlow pipeline are one of the most important features of KubeFlow. Is the qualified implementation of machine learning workflow in the form of DAG, which is again running on the need is kind of using an Argo workflow. So KubeFlow is using Argo workflow underneath into Kubernetes cluster. You can see that on the picture how it look like. We have different steps of the machine learning workflow. In this case, it was Azure Boost training. We have different steps, and each step is pretty much a controller running separately, and we kind of passing data between the different steps. I'm gonna take a break here. Anybody question? Am I going too fast? Is it? Feel free to interrupt me anyhow, ask any question if you feel like. I believe there's no question. Let's keep going. So now that we have an idea what Kubernetes KubeFlow and how, what is a different component of the KubeFlow pipeline, how do we build one? Right? So again, as I say, KubeFlow is a collection of KubeFlow pipeline is collection of steps of the machine learning process. Now, each step, we look at each step as a component, and a component is pretty much we can see as a container, right? As a container or as a port if you're using the Kubernetes semantic, where let's say you have a data cleaning or data fetching function. You write that function, then you put it that particular function into a container with an image of the container, and then you run it. Now that make it a component that can run independently and anytime, anywhere. And you do have a pipeline decorator. Again, pipeline decorator is just a way of creating a pipeline function. Well, now the pipeline itself is, again, in the pipeline is kind of put together all the different components that you already defined earlier. So kind of you can see as the orchestration of the different steps that you put together. In this case, you can see how on the image on the right, you can see how the simple train pipeline has create cluster or analyze or those are different steps, right? And each step itself is a component. Now, in this case, we can put together those a sequence of steps that are going to happen as we define it. And the pipeline step is, the pipeline step or stage is a way of invoking the component. And you compile the whole thing and then you run it. Okay, for a deeper look on how it look like in code, right? You can see the picture on the left side, very different sequence of steps put together. And then you can transform data. The transform data step, you can see how it consists of the function. It's a normal pattern function, right? That you run into a container. And as we know, a container needs to have what the container images. So you define an image. The image is pretty much a set of different dependencies put together, right? And you run it as a Docker. Yeah, that's now we have kind of quickly went over KubeFlow and Kube pipeline before jumping to the actual hands-on on building your own pipeline. Do anybody has a question like that? Feel free to answer.
Yes.
That's a great question. François en anglais, I don't in mind. Okay.
Yes, thank you for your presentation. I think 1 year ago, I tried to use it on a server with good capacity, but I rapidly abandoned the idea because of complication in terms of resource. So, do you think that it is good to use it on a single computer or on a single server, or is it good to use it on Amazon or another cloud provider?
That's a good question. Again, just to make sure I understand the question. So saying that you try to use that in the past and you have an issue with some type of resource constraint, it wasn't loading very well, it wasn't performing as you were expecting, correct?
Yes.
Yes, it's kind of a little bit require a lot of resources to run locally. So if you don't have a powerful computer, it may be slow, but it should be fine. There's a way of running it. If you're going to use, because KubeFlow is on top of Kubernetes, so you need Kubernetes to run KubeFlow. KubeFlow itself is light. It's a light package, but Kubernetes is very complex. It's a huge package. So you need to have a lot of RAM and a lot of this and compute power in your computer to run it. So most people don't want Kubernetes locally because it's requires a lot of resources. They're running on the cluster. It can be AWS, it can be Azure, it can be Google. But there's a way around it, right? If you use Minikube, Minikube is giving you a simple, lightweight Kubernetes version. And you can install Minikube on your laptop. Now, on top of that, you can download KubeFlow. And then KubeFlow is a bunch of again KubeFlow is a bunch of components, a bunch of features. You don't have to load all of them. Right? As I mentioned, there's notebook, there's pipeline, there's KTIP, there's serving. Well, based on your use case, you can say, well, all I want now is just to have notebook. So you only load the KubeFlow notebook on top of Minikube on your laptop. You only use one particular feature of KubeFlow. Now, if you feel like you have more space in your computer, you can install pipeline. So again, the way KubeFlow is an architect, you don't have to install the entire software or packages at once. You can install each at a time. Like right now, I'm using KubeFlow pipeline on my laptop. It's a normal laptop that everyone has. They want one. I have Minikube. Minikube is very light. It's running on the Docker on my laptop.
Okay.
So you can definitely run it. If you use Minikube, if you use pretty much a feature that you want to have on KubeFlow itself, not the entire. Does that make sense?
Okay.
Il va pas bien en même temps. Feel free to answer, ask question en français. Hein. On est bilingue ici, donc ça n'y a pas vraiment l'intérêt de toujours parler anglais. Donc, c'est juste parce que, comme j'ai eu ma présentation en anglais, c'est mieux que je passe en anglais également. Donc, ok, bon. Il n'y a plus d'autres questions. On peut jump sur le hands-on. On the hands-on, so I'm going to use a simple iris data set to train the model. Okay, the simple UC regression model, and then okay. So now to start, I need to install the KFP. Yes, I did not talk about KFP in the presentation. So pretty much KFP is the KubeFlow SDK. And the KubeFlow SDK is allow you to pretty much communicate with the actual KubeFlow engine in Python. But KubeFlow itself is built in Go language. As I mentioned, it was developed by Google in Go. Now, if you want in Python, then you can use the SDK now. The SDK will be going to give you a set of feature or function that you can use to wrap your Python code into a way that the KubeFlow engine or API will understand. So I have to load that KubeFlow SDK with the KFP, import few library there. This is pretty much the normal. This is normal machine learning workflow. I'm not doing anything different. Loading data set. It's right there. Nothing crazy. I'm loading that. Then do the train test split, which is again normal flow. Nothing again different from our machine learning process. Again, the training this classifier. I have a train data, and I'm going to use the logistic regression to and save the model after training the model. And this has something to do with KubeFlow. This is still simple, normal ML workflow. So it's, as you can see, it's not it's not really a big difference going from a big gap going from a traditional ML workflow to a KubeFlow workflow, right? Just one layer that you need to add at the end to wrap it up. And this is pretty much where I'm doing the inference. There on that. Yeah, make a prediction there. And then on the test data set. Then mirror is pretty much where you gather the metric. Gather the metric. This is the step where I'm using to download the repo. Right. Okay. So this is pretty much one step, which is getting what we're getting started. Now, the model is done. Then we're done with model, right? We model training, that is done, right? Now, it's when we're going to start using KubeFlow. Right? So this function is still a backing function, right? Where, well, I'm kind of what I'm doing here. I'm downloading my repo, and then the repo is where I'm having the actual data set that I need to be able to load that. Right? Now, this function is pretty much, I didn't cover this one, but it's another way. Well, there's two ways of making component. You can make component using container up, or you can use container using a component from func. Is that pretty much what we're going to use at the bottom. But this is another way to make component using a bash function here. I can just go ahead and clone a repo. Then that repo now is where I'm going to, I'm storing the data set that I'm using to train the model. Then now this is pretty much where I'm converting each of the machine learning function or step that we have above into a KubeFlow component. Right? The KFP component, create component from func. So I'm kind of converting the prepared data, which is what we have here, right? That first function we have prepared data. This function, which is normal pattern function that we have. Now I'm converting that function into a KubeFlow component, which require that I'm passing an image, right? Because an image contain images, and then the function name is what we have there, and the package that I want to install. So see, I don't have to install all the packages at once across all container. I can only pick, few packages I need for particular work to be done. So this is pretty much wrapping this first step into a KubeFlow component. And when it's done, now same thing with the second step too. And I put up into, you can see how I'm installing different packages, right? Each step have different package that I install. I'm still using a Docker image there. So Then same thing, next step, converting each step of the MFlow to a KubeFlow component. Create component from func. Same thing there. What is it doing? Yeah. Okay. Now that I define all the component, I need to orchestrate those components into the pipeline. Now it's time to build the pipeline. I define the pipeline. I'm using the DSL decorator. And this is the pipeline function. This is normal pipeline function. One difference between what make it the pipeline a KubeFlow pipeline is just the decorator that we put on top of it. But it's defined as a normal pattern function. I define the volume space pretty much in that particular in my cluster. I have a bunch of container, bunch of port. Now I dedicate one port to store all the data set. So this is pretty much what we're defining. The volume up is the you can see it as a storage for the storage center for all my, where I can put the data, where all my different components can access that data to. Because remember, each port has their own space, or they don't share the disk space. Now, to be able to share data between different containers, I need to have a central location where I'm putting all the data and allow every container to access those. So I define that there. Storage space for the workflow for the pipeline. Now that I have the component, the other thing that you need to know is how to move from container to component to a step or task or different semantic on it, but all the same thing. So pretty much you need to you're calling the component function here. That's it, right? And which what we have defined up here. You're just calling that. So you think, oh, well, in my pipeline, what I want to do to start the pipeline, first step is to do the prepare step. The prepare step is pretty much calling the prepare step component. Now, adding this parameter here is just to make sure, well, link that step to make sure the step is linked to the actual the central storage for the entire pipeline. Attach that data volume to your container step. Now, the next step is the join test. So you're just calling that function, that component as a function. You're adding that. You can see how I add dependency after the prepare step. That means I'm going to run this step after I complete the prepare data task. And clone the repo, satisfy the training, log predict, the same thing, right? You see what we're having as a DAG, right? It's depending DAG, right? Depending, you define each step and then put it into a DAG sequence of step with the dependency between step. And this is just a way of to cache your data. So if you don't want, if you run this pipeline twice, it's going to use the cache data. If you don't want that, just comment this part. So you don't have to do it again. Now this one that complete. And then this is one of the final stage of the workflow. You pretty much compile the entire pipeline or the step. You compile the step into a YAML. YAML, as I mentioned earlier, is the definition of the pipeline as an Argo workflow. So underneath, KubeFlow is using Argo. But you don't have to know, you don't have to understand how Argo workflow work, right? How to define work in Argo workflow, right? They will build the Argo workflow for you. And all you have to do, you need to load it in your KubeFlow engine. So here, compiling the entire Python script, and I'm loading that as saving it under the ARIS classified pipeline YAML there. And I can use this YAML file uploading to KubeFlow UI, or I can directly send I can directly connect to the KubeFlow API using the kfp.client connect to KubeFlow API, and from there I'm pretty much doing the same thing. Right? This is just metadata, nothing important here. So what matters is part. So this is pretty much the same thing as we did before. Pretty much this one. Yeah, it's the same thing that we did before, but with this one above here. But instead of pulling to giving me the YAML file, is going to put together a YAML file and send that directly to the KubeFlow engine. I don't have to load it manually. So if I want this step, it's running. Now I can go to my KubeFlow. I can go to my KubeFlow and show you how it's progressing. Yeah. So let me verify this one. This is what I just started running just now. I'll open that one. The first part is to set up the volume, which is the central storage space, and the prepared data is what's running right now. When I'm kind of loading data from the repo. You can see that you can look at the log, the live log there. I will take some time, pretty much. But to spare you on the time, I can show you what I already complete. A job that was done. I think I won one right just a few minutes before I started this meeting. So this is the previous job that one. You can see the volume as a central location. Prepared data is loading data from the volume, and the train test is getting from data from that, getting input from the prepared data, and download the repo, training the basic logistic regression model, and do some prediction there. The data set, and then get the metric. So that's pretty much the entire ML workflow that we did. And each step is running separately. You can see here, as I mentioned, that's the volume. If you're familiar with Argo workflow, or with Kubernetes actually, underneath, right? This is how you create a volume in Kubernetes. Right? You don't have to worry about it. If you into Kubernetes, you can look into this side of the underneath. What KubeFlow is doing is kind of it's a wrapper around Kubernetes. So you don't have to understand all the Kubernetes syntax. But underneath is going to be the Kubernetes workflow. Kubernetes, I would say, use case, right? Custom resource, YAML, spec, all of that. Then you can look at, if you look at the prepared data, So everything goes to a mini IO, which is a storage location. The log, open the log file. Pretty much there. Yeah, what is it? Okay. If I open the prepare data here, the log file, details, port. You can see the wipe in the port, right? And the event, if there's an event that happened there. So I made the data that we have. So yeah, that's pretty much maybe go to the one more step in the pipeline. If I go to train the model is trained, the log, the search classify train, now it's right there. So pretty much again, whatever log you put it in your script, you can see here. And the port definition is there. So yeah, that's pretty much what we have. Let me see if you see running. Yeah, you see running. So again, I think that's pretty much what I have for today. Any question? Question?
Oui, alors, merci beaucoup, Rikel. C'est très intéressant et complet. Moi, j'aurais une question sur la configuration même de Kubernetes, de Kubernetes, du cluster Kubernetes. Alors, je ne sais pas où est-ce que tu l'as fait. Le SDK, lui, il communique avec un cluster que tu as déjà mis en place. Ici, je pense, c'est Minikube, hein, c'est ça?
Yeah, Minikube, exactement.
OK. Donc, du coup, une fois que tu installes Minikube, le SDK, quand tu codes l'architecture de ton app avec Python, lui, il se synchronise automatiquement avec Cube, c'est ça?
Exactement.
Et est-ce
Oui.
qu'on a les options de configuration de Minikube, par exemple? Imaginons, on est dans une boîte avec déjà un cluster, des paramètres et tout ça défini, un endpoint pour l'accès au cluster. Est-ce qu'on peut le configurer?
Oui,
Je suppose que oui, avec un SDK.
Oui, so, normalement, si on a une entreprise, on va utiliser le Minikube, on va utiliser Kubernetes. Et puis là, il va falloir configurer le Kubernetes cluster, tu vas définir les paramètres d'authentification de ton Kubernetes cluster. Et puis, tu vas définir également l'adresse et les paramètres d'authentification de ton KubeFlow cluster. KubeFlow également, c'est un cluster dans un cluster. Donc, KubeFlow, c'est dans Kubernetes cluster. Bon, tu définis d'abord ton Kubernetes cluster, tu définis les paramètres de ça, tu vas tout authentifier. Et après, maintenant, tu vas t'authentifier également au KubeFlow. Et puis, ton SDK, maintenant, va pouvoir communiquer le client, va pouvoir communiquer avec le KubeFlow endpoint. From there, you can go from it.
Et du coup, là, tu as pris l'exemple d'un entraînement avec des données d'iris. Alors, imaginons que nous sommes sur du fine-tuning d'un modèle d'IA génératif. Est-ce que KubeFlow, lorsqu'on le soumet en fait l'entraînement d'un modèle, est-ce que derrière, il auto-scale automatiquement
Exactement.
ou on doit lui dire en fait, pour ce truc, j'aimerais que tu utilises, par exemple, 25% de CPU, tel nombre pour cent de RAM. J'aimerais pas que tu dépasses cette limite pour ne pas faire tomber, par exemple, le cluster. Est-ce que ça aussi, c'est une chose qu'on peut considérer?
Oui, c'est ça l'un des avantages de KubeFlow. Tu peux vraiment facilement scale. Et puis, tu peux également passer des requêtes par rapport aux ressources. Tu peux dire, bon, moi, je veux utiliser tel GPU T4, par exemple. Mais je veux utiliser tel CPU, whatever. Et si tu es dans le cloud, si tu es il y a plusieurs configurations. tu définis exactement ce que tu veux. Tu veux utiliser 2 gigas de RAM, tu vois, RAM, et 2 gigas. Donc, tu peux vraiment définir exactement tes paramètres. Tu peux le faire également.
Ok. C'est intéressant. Et aujourd'hui, KubeFlow et MLflow, c'est deux projets presque. Alors, est-ce que c'est
Mais
différent? Dans le
oui,
sens, c'est différent. Moi, je sais que l'approche d'implémentation, le fait qu'on passe MLflow, on va plutôt utiliser une machine standard. Et KubeFlow, on va utiliser Kubernetes. Voilà. Ah,
hmm.
mais d'après ce que tu as montré, c'est presque la même chose, en fait, dans le
Oui,
processus.
c'est exactement la même chose. C'est juste que QFlow est juste la version de Kubernetes.
Kubernetes.
Yeah,
OK.
exactement. Un peu comme tu as Jenkins et tu as Argo. Jenkins et Argo, c'est similaire, même chose, même. Jenkins, Argo, c'est Jenkins de Kubernetes. Donc,
Mm.
voilà, ils font les custom software packages for based on the platform. Ouais. So, MFlow, maybe c'est bien. Ça va. Il y a aussi Vertex AI, le nouveau QFlow de Google. Donc, oui, c'est similaire en même temps. Donc, il y a juste que, voilà, si tu veux utiliser Kubernetes, tu vas utiliser QFlow. Kubernetes allow you to auto scale. Par exemple, parce que c'est Kubernetes qui est responsable de scale. C'est Kubernetes qui est responsable de définir que si tu veux un port avec des paramètres, il définit tout ça en fait. Ça, c'est Kubernetes work. Which we don't have, tu n'as pas avec MFlow. MFlow
Mhm.
ne va pas te donner l'option de pouvoir configurer tes paramètres, ton cluster et te scale comme tu le fais avec QFlow, parce que QFlow, c'est également Kubernetes.
OK. OK, non, c'est intéressant. C'est vrai que moi, personnellement, j'ai déjà regardé, mais je n'ai pas encore vraiment utilisé. Je suis aujourd'hui beaucoup plus du MLflow pour les parties expérimentation. Et c'est vrai que quand même, bon, en même temps, on n'a pas de cluster Kubernetes. Si on avait un tel truc, ça aurait permis peut-être de tester un peu la plus-value de Kubeflow. Mais oui, c'est très intéressant. En tout cas, c'est encore beaucoup plus intéressant aujourd'hui avec les modèles d'IA génératifs.
Oui. Avec le modèle génératif, tu as par exemple, un exemple simple. Si tu veux créer un modèle génératif, tu as besoin de GPU, par exemple.
Mm,
Et si tu traînes 400 modèles, comment tu fais avec une machine? C'est impossible.
mm,
Avec QFlow, tu peux avoir chaque modèle comme une différente step. Ton modèle 1 rentre sur le step 1, modèle 2 rentre sur le step 3, modèle 4, et puis maintenant, tous tombent sur le cluster, tombent dans mon cluster. Et puis, Kubernetes va find a way to give it d'alloquer les ressources pour chaque modèle. Ici, dans mon cluster, il y a beaucoup de machines qui sont puissantes. Donc, je peux, par exemple, avec un clic, je peux faire environ autant d'expérience que je veux. Avec un clic. Et sans plus trop un impact sur les autres, parce que bon, tu peux le faire également, mais d'habitude, quand tu le fais, c'est conscient. C'est-à-dire que s'il y a un qui ronde, les autres vont attendre d'avoir que le fini, mais là, maintenant, tu peux le faire en parallèle. En parallèle, bon, avec, bon, c'est ça aussi, hein. Plus ou moins, bon, tu vois, le critère c'est plus ou moins sur when you're going to be on the enterprise. Ouais, si tu es dans un truc bon, ouais, un petit projet, donc, c'est pas, tu vois, de Kubeflow, c'est pas vraiment comme ça, mais quand on parle enterprise, scaling, um, of training, scaling of serving, of deployment, then that's why you kind of use Kubeflow. Et puis tous les cloud providers on devait intégrer. Pareil avec Kubernetes. Ils savent que voilà, c'est l'un des main use cases pour, for machine learning tuning.
Mais oui, parce que typiquement, en fait, aujourd'hui, ce que fait Google sur sa partie Vertex AI, c'est du QFlow derrière. Hein.
Non, mais
Dans le,
exactement.
ils ont implémenté du QFlow directement dans le truc. Ouais. Il n'y a rien à
Mais
changer.
en fait, KubeFlow a été créé par Google. KubeFlow a
Oui,
été
c'est
créé
ça,
par
en
Google.
plus.
Yeah.
Ouais.
C'est Google qui a créé KubeFlow. Bon, au début, Google peut voir, puis on release KubeFlow au public. Bon, maintenant, tout le monde a eu l'intérêt dessus, tout le monde a adopté KubeFlow. Mais après, bon, maintenant, comme tout le monde est sur KubeFlow, ils essaient d'avoir une version plus ou moins deep, spécifique. Bon, ils ont créé de nouveau KubeFlow qui est peut-être AI. Hein, voilà. Bon, c'est similaire, c'est totalement similaire. Bon, c'est vrai qu'il y a deux, tu vois quelques, quelques features qu'ils ont améliorées, mais c'est exactement du Kubeflow. Il n'y a pas vraiment de différence.
Ok. Bon, moi, j'ai plus d'autres questions. Je ne sais pas si les autres ont des questions.
Yannick, Tatiana, à vous.
Pas de questions de mon côté.
OK. Bon, là, il y a le YAML. Bon, ça, c'est, voilà, comme je disais, derrière, quand Kubeflow Pipeline compare, le pipeline, ça sort, ça formate tout le Python script into a workflow, as I can see. Donc, ça, donc, je passe sur Kubernetes. En Kubernetes, je gestionne on sécurité. Again, this is underneath. You don't have to know about it. Again, this is, si tu es en train de débugger ton projet, bon, là, tu vas forcément tomber sur le YAML file de ton pipeline, ici. Et bon, là, c'est bon, là, c'est couvert déjà. C'était juste le component, the function component. Okay, there's nothing else. No more questions. I think we are good. Yeah, thank you. Merci c'est tout ce qui ont pu retenir la présentation. J'espère que ça va vous aider. Hein, et voilà. Bon, s'il y a des questions du Qflow, il ne faut pas hésiter de me contacter. Je peux vous aider. Vous savez que je suis un membre. Bon, je contribue dans l'open source de KubeFlow. Je suis un peu actif là-dessus. C'est un peu d'être plus actif parce que comme c'est open source, ouais. Tout le monde a accès à ça et tout le monde peut contribuer. Voilà. Donc,
J'ai une question. Je ne sais pas, est-ce que tu as envisagé peut-être la rédaction d'un petit tutoriel sur ça
oui, là,
pour
c'est une idée. Là, c'est une
Medium
idée.
ou quelque chose comme ça?
Là, c'est une idée. Bon, là, s'il y a une audience, ça dépend. Bon, pour l'instant, bon, j'ai pas d'audience. Pas d'audience qui en demande. Et si j'en ai, bon, voilà, je peux
Oui.
facilement dire, je peux le faire, pas de souci.
C'est ton contenu qui crée l'audience. Hein.
Oui, bon, ça dépend de, bon, si tu vas dans l'option de YouTube, oui.
Non, je parlais des sites comme Medium où tu
Ton
auras des
médium, ouais.
références.
Ah, si, oui. Là, c'est aussi ça. Là, je peux le faire. Je peux le faire. C'est une option. Bon. Puis, également, c'est pas, euh,
Ou, ou même, ce qui serait encore mieux, c'est que tu fasses un tuto et on publie dans le blog de l'assaut.
Yeah, yeah. Mhm.
par exemple.
Ouais.
Yeah.
Ouais.
Mhm.
Et d'ailleurs, je pense que cette année, ce qui serait intéressant, c'est effectivement de regarder, en plus de ces points techniques, peut-être de faire des petites rédactions, effectivement, soit de tutoriels ou sous forme de rédaction d'articles sur un sujet précis
Ouais.
et qu'on va publier à la fin, en fait, de ces points, que l'on publie au moins une publication ou un article par mois. Enfin, pas scientifique, hein, juste un article de vulgarisation ou sur un cas
Mhm.
d'usage. Voilà. Par exemple, comme ce que tu as fait là, on peut maintenant prendre un cas de données en langue africaine et
Mhm.
on applique une méthodologie avec un flow, on présente un peu.
Yeah. Mhm. Yeah.
Ça nous fait un très bon cas d'usage à présenter et à lire.
Exactement.
Et là,
Yeah.
ça peut créer de l'audience. Ouais.
Yeah. Ça fait évidence, yeah. Mhm. Yeah. Ça, c'est une bonne idée, hein. Bonne idée. Bonne idée, vraiment. Et puis, bon, si on peut déjà, dans le style de l'assaut, on peut avoir une section bon, recherche, bon, l'assaut, bon, recherche ou bien R&D,
Il y a
ou
déjà
bien
ça. Il y a
training.
déjà ça.
Là, on met juste, on met les slides dessus. On peut avoir une section training. On peut publier les slides, par exemple, ou bien les recordings. Bon, recording, peut-être pas, mais les slides, peut-être, l'article, oui. Euh,
Il y a l'enregistrement qui est sur YouTube, de toutes les sessions d'ailleurs.
ah,
L'enregistrement, sauf que effectivement, bon, YouTube, c'est pas tout le monde qui. Il y a des gens qui regardent, mais sauf si on crée peut-être un autre format, peut-être
hmm,
un peu plus mieux construit. Moi, j'ai l'impression que ce format, il est long et forcément, il faut aussi retravailler la vidéo, il faut ajouter des animations, tout ça.
hmm,
On n'a pas forcément le temps de faire ça. Mais peut-être que l'idéal serait une fois qu'on a fait, de simplifier avec une vidéo. On peut même créer un concept. Moi, j'y ai pensé, c'est de dire, on a une techno, en 5 minutes, on explique la techno
hmm,
et, et on présente comment cette techno peut être utilisée pour les langues africaines.
hmm, hmm,
Par exemple, KubeFlow, 5 minutes, c'est ça, c'est ça, c'est ça, cas d'usage, ainsi là. Et du
hmm,
coup, ça permet, maintenant, on dit, pour ceux qui veulent en savoir plus, on le redirige maintenant vers l'article qui parle en détail maintenant du truc.
hmm. Yeah. Yeah. Là, c'est mon idée.
Ouais.
Mon idée. Mon idée.
Du coup, alors, maintenant, il y a un autre point qu'on voulait voir, Moussa, c'était sur ton sujet du challenge encore. Et du coup, comme je disais, moi, de mon côté, je pense que c'est un très bon sujet. C'est un très bon sujet. Mais bon, maintenant, effectivement, il faut qu'on trouve la langue.
C'est ça.
La langue et qu'on trouve les données. C'est le plus difficile. Ou même, est-ce qu'on ne pourrait pas commencer? Est-ce qu'on ne peut pas commencer simplement? Au lieu même d'attaquer directement le côté algorithmique, est-ce qu'on peut pas faire une session, première section, où on dit l'idée, c'est de créer de la donnée dans
Bon,
une langue.
moi j'étais parti, en fait, j'avais eu une fausse bonne idée. C'était de se dire que j'allais prendre l'alphabet français